Have Lisa Carloye from Biological Sciences, and she'll take over. Thank you.
All right, well, that was a very colorful presentation. Mine is kind of black and white because it's the end of the week. So my presentation is called Drawn to Learning. So I have been teaching for a very long time, and I have small classes and gigantic classes, and I have to choose textbooks all the time. And I've come to the point in my career where I feel very frustrated that the students seem to come to my classroom believing that their goal is to memorize stuff, and that the way that they know if they have memorized this stuff correctly is by answering questions. And I've gone through this process of trying to choose a new textbook, and the textbook, most of the textbooks basically say, read this and then answer these questions, answer, answer, answer. And I feel like you don't really answer questions as a way to learn. You learn and then you answer questions to demonstrate your understanding. And so I have really shifted to trying to use sketching as a way to help students get away from memorizing stuff to be able to see processes. And this is really especially true for processes, because it's not, I mean, I always say this is a movie, not a picture, right? It flows. And so I've really been thinking a lot about the memorizing versus learning. So yes, you need some memorizing in order to learn the vocabulary, to learn pieces, and memorizing is a underpinning of learning, but learning is really more about understanding. But students really think that memorization is what is most powerful. That's what they want to do. That's what they have been rewarded for. That's what they've been taught in high school and other classes in college. And I think that a lot of their lack of willingness to let go of memorization and actually try to learn processes is that they don't have the confidence in themselves. That if you memorize something, you've got a fact, right? And if you ask me this on the test, I know the answer. I may not understand it, but I know the answer. And of course, that's what my goal is. And so I feel like part of the challenge in getting students to back off of memorization as the end goal is that lack of confidence in their ability to understand these processes. And I feel like because of my textbook and the way that we do tests, and we basically try to see what students know by asking them questions. And I think that having opportunities to get to the learning part and then ask questions is really important. Okay, because the goal for learning is to actually understand and not just to know a bunch of random stuff. Okay, and part of that hallmark of understanding is being able to use what you know and do some critical thinking and think about like what would happen next or what would happen if you change something and things like that. And I also try to tell students that if you understand the concepts, that if you come to a question on a test and you don't know the answer, all is not lost, because you can figure it out. You probably can figure it out. You've got a good shot at it, as opposed to, I didn't memorize this, I didn't know this question was coming, and I don't know, therefore I don't know. Okay, and so specifically learning processes. So I have found in my classes that students really struggle with cause and effect. I don't know why, but they just really struggle with cause and effect. This happens and causes this, and then this happens next, and this happens next. And so I've built more things into my teaching to try to help them develop that ability to think about cause and effect and those sequential kinds of processes. And what I've come to is that really processes are stories. They're things that unfold over time. You start someplace, something happens to the main character of the process, and things unfold and change, and then you come to some end. And so I started trying to tell these processes as stories. And then I tried to really emphasize this sequential thinking. If you're going to learn a process, you have to really engage in sequential thinking, not, just spot pieces of stuff. Okay, and so sketching is my rescue sort of a thing. So I use the document camera in both my gigantic classes and my smaller classes, because at first I would just do it on with an animation on the screen with a figure from the textbook. And there's too much removal from the students can't recreate what's on the screen. And so I ditched that. And now I use the document camera and I sketch it with them and have them sketch it with me in real time so that I can show them what to do and what the steps are. And I can talk and narrate the sketching. Before I start to sketch it, I do try to give them an overview about what is this system accomplishing. This is the circulatory system. We're going to circulate nutrients and gases throughout the whole body, right? And we're going to have a pump in the middle that's going to push it around. One of the keys that I really have to emphasize is that this is not about art. And in fact, if you are an artist, you need to let go of that, because what sketching is really trying to distill the essence of the system, capture the key features of it. Don't try to make it, an anatomically correct heart. That's not the goal. That what we want to do is identify what are the key features and distill them. Stick figures are better than fleshed out beautiful things because we're trying to capture the essence. And in order to do that, we have to identify, well, what are the key features? And that's part of the learning process, right? What is the key action that's happening? What are the components of the system? And how are they going to all connect together? Because it's a process, things move and change over time. And so drawing arrows to show movement of things and then labeling the arrows helps to capture what the dynamics of the system are. So it can also distill, that. So I'm going to show you, I guessed right that there wasn't going to be a document camera. So I did this by hand last night, so I hope it works. So I'm going to show you how I do the circulatory system. So the circulatory system has some key components. We're going to draw a heart in the middle, and a heart is just a box with 4 chambers. And then another component of the system is the lungs. And we're going to write the lungs above the heart. And then the body tissues. And there's body tissues both below the heart and above the heart. And that's it. Those are the key components of our system. So now we need to actually connect all of these with the tubes, right? With the arteries and the veins. And so we're going to draw an artery going from the right ventricle to the lungs. And then we're going to draw a vein coming back to the left atrium. And we're going to capture that. And then we're going to do the same thing. We're going to capture the aorta. We're going to capture the artery leaving from the left ventricle, and it's going to branch. I didn't quite get it up there. And go up to the body tissues and come back to the right atrium, and then do the same thing going from the bottom and connecting it up. Those 2 lines are supposed to actually meet at the atrium. Okay, so then at this point, I can tell students, sketch it, erase it, sketch it, erase it, sketch it, erase it. Quit looking at your notes. Do it until you can do it like that. No problem. You got it. You got all the connections right, coming out of the right places, going back to the right places in the heart. You don't have to learn the whole system at once, the whole dynamics. You just have to learn this until you get it. And then we can layer on. Here we go. Then we're going to layer on. I'll come back to that slide. We can layer on the dynamics. Okay, so we're going to add the gases, right? So the gases are the actors in our story. So oxygen, we're going to put it in the lungs because that's where it enters the system. We're going to grab CO2 and we're going to put it in the body tissues because that's where it enters the system. And then we're going to have a red blood cell and we're just going to put it in the right atrium. And once we do that, then all the actors are in the place they need to be before the action begins. So now we're ready. So then, and I didn't do this for clarity, but then you would also stick a CO2 molecule on the red blood cell, okay? Because that's what it's doing, is carrying CO2. So we're going to drop down into the ventricle. We're going to head out. The only place that we can go would be the lungs, and that's where we're going to let go of the CO2, pick up a load of oxygen, and bring the oxygen back into the heart. And then we're going to drop down. We're going to go out, and then we're going to go to the body tissues, and we're going to deliver the oxygen. We're going to pick up a load of CO2 and head back to the heart. And then we're going to do the same thing. Oh, I didn't do the same thing up above. Okay. And so this is what I have them do. And they can learn this process and show the dynamics of what's happening in the lungs and in the body tissues. Oh, this, I have my slides out of order. Okay, I'm gonna go back. Oh, okay. So once I do that, then the other piece is that we have to repeat the sketch, because once you do it once with them, they're just following along. And I've been surprised that we don't know, they don't know how to do this on their own. So we have to keep repeating it through the whole thing. So I just want to show you a couple of student sketches. So this is what the students did. We first did the system. That was one lecture. And then the next lecture, we added in the gases and added in that dynamics as well. And then for assessment, for my small classes, I actually have them sketch it on the exam. So this is from my final yesterday, sketch the circulatory system. I give them a little grading rubric on the side. I also put some multiple choice questions in the body of the text to see if they really are making the connection. If I can say the blood is in the right atrium, where is it going next? Or you're in the lungs, what gases exchange is happening? So try to connect that with kind of standardized questions. Okay, so does it work? I would say yes. They start to really see the dynamics and the picture and the story. But what I have discovered is it takes a lot of repetition. And for my big classes where I can't grade them in lecture what they're doing, the buy-in, it's really hard to get buy-in. Students, yes, we did it together, but I never did it for studying. Yes, I did it together. So I try to get them to office hours and emphasize sketch, 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 sketch. So that's my boots on the ground. Okay.
Okay. Yes. Okay, thank you. We have our next speaker, Long